So welcome everyone to our machine learning integrity panel here. We're gonna get started. Make kind of brief introductions. So I'm Yaron, CEO and co-founder here of Robust Intelligence. And Wade, you want to start?
Hi, I'm Hui Wang. I manage the global analytics and data science and machine learning team for PayPal.
I'm Jack Berkowitz. I'm the Chief Data Officer of ADP.
My name is Ting. I'm the Chief Data Officer for Rakuten and also the Director for Technology Services.
And I'm Ed Bowen. I'm the Head of AI for Deloitte Advisory.
Right. So here today, what we're going to talk in the panels, we're going to talk about like machine learning integrity, like what it is, what are some best practices, right? What we should all be thinking about, as organizations, as developers, right? When we want to avoid or eliminate, risks of AI and ML, right? And instill integrity into models and data systems. Basically, I want to start us off with with a question of like understanding how we weigh the trade-offs. So when we're thinking about companies, there's always this pressure to innovate, right? Where we're using AI, but that pressure to innovate is there's a trade-off, right? With the inherent risks that we have with AI adoption. So how do you think companies should kind of think about this trade-off?
We will start. I think the first and foremost is actually about a mindset change. We started going back a few years with, again, exactly saying, okay, if we want to be responsible, then we cannot deliver the best product. Actually, over the years, we've kind of changed our people's mindset. You know what? These two actually goes hand in hand. Once we have integrity, responsible AI, at the end of the day, it actually helps make our business outcome better or help make our product better. So that's kind of a mindset change. And on top of it, I think the alignment across different parts of the company, and then also with a well-structured responsible AI program, the process to support it. So all these things come together, kind of helping the company make the best trade-off decision when it comes to ML integrity.
Yeah, and I'd continue that. So the way we look at it is that it's a springboard. It's actually the springboard that gives you the confidence and the trust for the company to take the innovation risk. So when we started, our program, over 3 years ago now, it started with setting up our data and AI ethics board to start. And then from there, we were able to then move into data platforms, now move into, responsible AI platforms. That allowed us to have that confidence, to have the discussions. It is a mindset change. People have to talk. Without people talking, then you can't make the advances.
Yeah, I want to echo Jack's point on the confidence and the trust. That's super important. I work at Rakuten. It's cover a variety of businesses from fintech, mobile, and e-commerce. And the speed and innovation is at the core of Rakuten culture. But the best way to move fast is to make sure that, we are prepared for the worst case. How do we prepare for the worst case is really have, what you guys are doing is super important to make sure we have the integrity of the model, to make sure that we prepare for the risks ahead of us, and then we can go fast, right? And when I joined Rakuten, one of the first things I want to do is not AI model, it's really unit test. To make sure that we have comprehensive testing, then we can move fast. Then we have the confidence to move forward.
I agree. Yeah, I think a big part of this is about being able to scale. So I think early on, there was a lot of innovation happening. There was a lot of, the AI leaders were primarily in the tech sector, and they were going very fast, and they were creating a lot of value, and they were growing rapidly. But that's also where you saw sort of the biggest events that were negative, and where people started to find out about what happens when you have a non-representative data set and you train a model and you put it out there to make some key decisions. Some really bad things can happen, unintended consequences, right? So now we're moving much more broadly into other industries, and you look at industries like life sciences that are heavily regulated. They're working on medicines, they're working on companion diagnostics and oncology. Like, you can't put a model out there that you don't have a lot of confidence in that's going to make the right decision around somebody's tumor phenotype so that they get the right drug to treat them, right? You have to have a lot of confidence in that. And that's why what you're doing here is so important, because patients are waiting for medicines and to figure out which medicines they should have for their tumor, for their disease. And we have to have a lot of trust in these models. The regulators, the FDA, others have to have a lot of trust in these models before they'll use them in that context. So having tools like this is critically important for creating that trust.
Oh, that's fantastic to hear. And yeah, I think testing is something that we do in software, right? And it's something that with the software engineering, we have kind of like, I don't know, over 40 years, right, of I think kind of best practices like kind of developed. And I think kind of when we're thinking about AI, it's an engineering discipline. It's a relatively new one, right? And kind of like in putting those kind of frameworks in place is something that's still relatively new, right? So I'm kind of like I'm curious to hear your opinions on basically like kind of the ownership and accountability, right? So obviously we're at this point I think nobody needs to be convinced about the benefits of AI, right? But what we're starting to see is we're being exposed to the risks, right? So now that we're kind of like exposed to the risks and we kind of like have a better understanding of this, it comes a question of like in an organization, right? Where like who's accountable for the risk? Who should own risk, right? We have like developers who are building models who are using kind of open source models, right? We have managers, we have VPs, we have compliance officers, right? So when it comes to like when it comes to AI, who do you think should own risk? So in my mind,
there's sort of a RACIC type of thing. What's responsible? What's accountable? Who owns it? I see it as being each person, each role in the process of developing and deploying models shares some accountability for that risk, right? And then you can have most organizations have some kind of compliance and risk function that looks over things like software development. And I think those concepts do apply in an AI world. I mean, what we've done is similar to you'd have a software development lifecycle, we have a model development lifecycle, and we create artifacts and, test the documents and all of these similar types of artifacts that you would have around software development processes, and we just apply that to AI and machine learning. You get into lines of defense, like first line of defense, second line of defense. I'm a big believer, and it starts with the data scientist, right? The data scientist really has a responsibility to understand what problem they're trying to solve, what data do I have to solve that problem. More and more, we're encouraging companies and people to not just think about, well, what data do I have, but also think about, what data do I need to collect? Do I need to start putting sensors where I've never had a sensor before? Do I need to run experiments to generate data that maybe doesn't exist today? But how do I create a more robust data set that's going to be able to answer the question? And how do I account for bias, right? And so giving data scientists tools to be able to understand how data sets are biased. Every data set is biased, right? But understanding that bias and mitigating that bias quantitatively, it starts with the data scientist. And then as you move up through the organization, having quality and risk management functions that look at the good work that the data scientist has done, looks at the evidence and can say, yes, we've stepped through the right processes. We've quantitatively measured our models. We understand what we're putting out to our clients and customers, gives you a much better safety posture in terms of the AI models that you're putting out to your clients.
Mm-hmm. Yeah, I also believe that data scientists play a critical role. And I'm a big believer of clear accountability. So I think the AI risk is so huge that it impacts the reputation of a company, right? And therefore, the CEO is ultimately accountable for the AI risk. And at the company I worked at, the accountability is codified through OKRs. And OKR is, there's top-level OKR, but also, I want to emphasize that OKR, at least at the company I worked for, it's not cascading. It's also enabled the frontline people to innovate, right? Because you mentioned data scientists, engineers, they know what they do the best at the frontline. So it's both top-down and bottom-up. So we can collectively create an OKR for the entire organization that has the best knowledge of strategy, which is top down, right? Like, but also have bottom up. Like when you work on a particular model, what are the things you need to be responsible for to ensure the integrity of the AI model? So collectively, everyone through OKR, have the responsibility to make sure that the entire company is accountable for the AI risk.
The point about the accountability, though, and it is shared, but you also have to be careful that it doesn't drop in between different folks, right? And so that also then has a responsibility for people to lean in and to cover over on top of each other to find the pieces broken, right? Is it a model that's broken? Is it the data underneath that might have shifted or drifted? Or maybe the data feed itself is broken, right? Or maybe it has other corresponding actions. So at the data scientist level, those things have to happen. At the data engineering level, those things have to happen. At the business leader function, those things have to happen. And everybody has to be working together in order to ensure, it's great to say the CEO is responsible for it, and he is, or she is, better yet. They are responsible for it. But it takes the community of the entire company to allow that CEO for they to be able to have that confidence to field and continue to develop these models.
Love the OKR idea. So I think the one thing we actually put a special focus, emphasis on is when it comes to ML integrity, the first line, the scientists and engineers, is actually play a super critical role. It's not like in the second line or MRM functions responsibility. So we actually make it very clear. I guess as scientists or engineer, we can all say it's much easier when you design a solution with this in mind than to go back and fix it. So that's the kind of one thing we emphasize. The other thing I think Yaron will talk about, executive is also important because at the end of the day, the leaders get to shape an organization's culture, value system, all the things, right? So we at the PayPal, we actually have a company-wide responsible AI steering committee. We actually get the highest level leaders together like every quarter to review what's out there, where are we, and also what are we doing to be ready or stay ahead of the curve. So again, I want to emphasize executive also plays a critical role.
Yeah, and I by the way, I also really love the idea of of OKRs, and I think it's I think it's easy, to kind of like focus on like kind of performance metrics, right? And to sort of say, for data scientists, like, okay, we're gonna push for the models to be, this more accurate, this much more accurate on kind of like maybe on a broader set of data sets, or even, for the business, it's like, we use AI maybe to get this much more business this quarter. But like, I think that the things that, maybe, I think as a community, we're not capturing enough of are kind of like other metrics, right? That that are important, when we're measuring quality of AI, that are beyond performance, right? And some of them, and all these things I think kind of have to do with like ML integrity, right? They have to do with like obviously like the operational like aspects of them, like making sure that the models are performant, right? That they don't fail on missing features or things like that, right? But also things related to security and also I think kind of fairness and bias, right? So, on that, I'm kind of, I'd love to hear from you guys on basically on how do you think, very pragmatically, like how do you think that we can, enable organizations to make AI models, just, more fair, less biased, right? I think a big thing of, for me, like a big thing that helps me kind of like, get up in the morning, right, is the fact that like I know, with the things that we do that, it's, on a very technical level, it's about stopping model failures, right? But I think kind of on a kind of like the bigger mission perspective is when you think about kind of like all these models that we're putting into production, right, that then end up affecting, actual people's lives, right, who are kind of affected by automated decision making, right? Then an important part of it is like for us to understand is like how do we make sure that these models that we're putting in place, they're we're mitigating kind of like all the the potential biases. So how does one like practically do that in an organization?
So if you think about these models, whether it's about credit risk, I work in the HR industry, so it's a lot about employment. These things, as you were saying, affect people's lives deeply. Right? And if the models are not being able to be identified in terms of bias, right? You're not going to be able to eliminate bias from anything. And it was mentioned earlier. The data exists, data is biased, sampling is biased. So I think the biggest practical aspect is the fact of taking the first step to measure. If you don't measure, if you're not spending the time to measure where you were, where you're going to be, and then set targets as to where you want to be, then you're not able to actually correct for anything. The second part of it is once you are measuring, it's not a one-time function. Data moves, models move, the environment moves. The world we're in today is different than the world it was 3 years ago. It's going to be different yet again 3 years from now. And unless you're continuously monitoring these situations and making proactive decisions to bring things back into line, adverse effects are going to happen. So it's really not about guaranteeing no bias. Whenever I see that, I kind of cringe, right? But it's understanding what that bias is and reflecting it and shaping it into making sure that there's not negative outcomes for people that are inappropriate.
Yeah, maybe I'll build on top of Jack's idea on measurement. I think there's a lot of data scientists in this room. Metrics is kind of core of what we do. So one problem I look at in the past is how do you measure diversity, right? Like I spent, before Rakuten, I worked at Google on local search and worked at Microsoft on Bing, news search, product search, etc. So on search engine, if you look, so image search, for example, right? You search for American CEO, does it reflect diversity and how do you measure that? When you think about local search, looking at all the merchants, do smaller businesses have a fair representation, right? And similarly for e-commerce, are we only showing popular sales item versus, hey, giving user more variety? And so these are the interesting problem to solve, and how do you measure that? And so that's actually a pretty interesting problem of its own, right? How do you measure and ensure diversity, fairness in our product results?
And part of that is including the data so that you can tell if something's diverse, right? Sometimes it's hard to do that. How do you get that list of classically disadvantaged business owners? Where do you find that? And it's easy to just forget about that and just move on with the data that you have. But it's taking the conscious decision to include that type of data or that type of coding into your model or into your evaluations is something that all of us in the data science community have a responsibility to do. And it's easy to sit up here and say it. It's a lot harder to put it in practice, but everybody should look to do that type of inclusion into their data.
I think that goes to transparency, right? So for me, it's transparency gets talked a lot about in terms of being transparent with the person using the model or who it's going to affect. I think it's also about making some of this transparent to the data scientist who's building the model. As we're starting to commoditize data science, like more and more people in the organization are starting to do data science. We're teaching the skills not just to computer scientists and data science in their university programs, we're teaching it to more people. We're training a bigger chunk of these organizations to do data science. They're starting to use tools like AutoML that can build models for them pretty easily. You start to fall into some of the traps, right? Some of the things that you learn as a data scientist that you don't do. I mean, the pretty classic one is around accuracy and imbalanced data sets, right? So you come up with in the first 3 months of COVID, if you had a test that said you were, 100% of the time it said you were positive, well, it was 99.9% accurate because hardly anybody had COVID back then, right? A useless test, a model that does something similar is also useless. But the metric, they throw it out, I'm 99% accurate, I must have a great model, when you don't, right? So how do we equip these novice, early career or early on their data science journey, data scientists with those types of tools so they don't make kind of those kinds of mistakes? The other part of it's a little harder, and it's kind of understanding your discipline, your domain. So when we're building classifiers for tumors, you really drive which medicine they get based on the molecular phenotype of the tumor. So you'll hear things like PD-1 tumors and immunotherapy, or BRCA-positive tumors and breast cancer. There's all kinds of molecular markers. And what we were trying to, what a lot of people were trying to do was take images of tumor slices and use those to train variations of convolutional neural networks. And you would then be able to run a new image in and classify it. But what people didn't understand, if you were just a pure data scientist, is tumors aren't always homogeneous. So sometimes you get different types of molecular phenotypes within the same tumor. And if you were trying to train your classifier based on that, you could actually get wildly inaccurate results, right? So it's kind of understanding your domain that you're working in, understanding the data and what it means, what does it represent, what's the context, but then also giving, especially the early career data scientists, more information about their data sets, the profiling, giving them tools to do profiling, giving them tools to help understand what the metrics around the model performance look like and what is an appropriate metric for a model like this. That's often a hard problem for some folks.
So this is actually an area where we say like a human and machine actually are working together in PayPal's case. So in addition to the process and the number and the OKRs we can set up, for some of our highly regulated processes, we actually have, we call like a super agent. And these are human beings actually constantly reviewing the machine learning output, of course, only a sample of it. And we use machine learning, by the way, to select the most representative or most interesting sample. And then through that, we actually ensure, again, the privacy requirements are met, and also can be looking for the next blind spot of the current solution and use it as a feedback to constantly make our solution better. So that's one thing I think interesting we are doing. Last but not least, I think we are still looking for technology solve. There are still, like nowadays, lots of research about safe machine learning. We are also investing in things like AI on device, which kind of intrinsically reduce the privacy concern like dramatically, right? So we're still looking for technology solve for these kind of solutions.
I also find too, like it's interesting this pairing of human and machine and sort of how things adapt and adjust over time. You know, the monitoring of the model's performance in production becomes hugely important because there's both how the human interacts with the machine in a positive way. Say you're trying to monitor healthcare fraud and you're trying to decide if something that happened was fraudulent or not, and you get support from the output of the machine learning model. But the adversaries on the other side are also adjusting their tactics, right? We see that in cybersecurity. We do a lot of cyber work at Deloitte. We do a lot of healthcare fraud, financial fraud, and the adversaries update their tactics. So when things start to get detected and caught, they then adjust and do something different. And so if your models are built to detect a certain type of like a lateral movement attack or something like that, and they keep getting caught, they'll start to shift their tactics. So having sort of adaptable models and anomaly detectors and things like that kind of look for the new and novel, never tried before types of attack patterns is also really, really useful.
But getting back to that issue or that essence of a person, right? In our AI principles at ADP, that's the first statement of our principles, is that there's a person involved in understanding and monitoring the models. So we can put as much automation in place as we want, but our first principle, and we have 7 principles, but the first principle is that this is a human-machines partnership and not just a machine by itself.
Yeah, I'm also a big fan of that human and machine partnership. Like I worked on news for a while. Initially I was thought that AI model is going to do the automated recommendation, right? But there's just always those sensitive geopolitical issues in the news world that it's really hard to automate everything. And the rules, the editorial tools continue to play a huge role in the project I have done. And Rakuten also work on medical research. The example that you mentioned on the tumor detection is also very important. I would echo that the tools is particularly important, especially for some of the smaller businesses where we apply AI model. There's not like 1 trillion of documents the search engine can analyze, right? This is where the tools become super important, where you can curate a smaller but very good data set, for tumor and for those targeted applications. So the tools and good data becomes far more important than when you don't have a large data set.
So like let me kind of double click on this a little bit. So you think that when we're thinking about kind of the basically kind of like the AI plus human, do you think that that's the key to success for getting kind of like widespread adoption of AI in the organization? Is that?
I think it's critical, at least in the application I'm working on, in the sense that, I'm working with a lot of business people as well. They have a lot of business acumen, years of knowledge, right? But sometimes I give them an output of deep learning neural network, which is I cannot even explain why. So it's difficult to combine their input, combined with the machine output, right? Like if we can actually explain, identify the key insight, and then with that kind of feedback loop, we have the potential to drive adoption. Something that marketers and business owner can actually understand, and then combine with their years of experience to continue to enhance the model.
So I'm curious about to learn more about the secret, right, of getting organizations to and businesses to adopt AI, right? And so on the stage we have leadership that's been responsible for creating billions of dollars in value by adopting AI, literally. So I'm curious to hear from you. How do you get the business to basically adopt AI at scale? How do you get them to be comfortable with the risks?
I think you hit it right there, right? It's that idea of defining the value in a way that's understandable by the business or by people, not model accuracy metrics, and the lift at map at K, or map at 5 or map at 10, right? But the impact of that into the lift, if you're building a product recommender, the lift in it increased sales, or the savings in some process, or in the case at ADP, we did an interesting project, and we've talked about it, about helping people reduce pay equity gaps into a multi-billion dollar opportunity for businesses. This getting down to the value that drives the company or drives the decision, or in the case I would imagine in cancer, for survivors and for people to survive cancer, getting down to those values of which the mission is for the machine learning. I think about this a lot. Machine learning and AI technologies, if they're not built to be goal-seeking, they're not going to be optimized. But that goal has to be in terms of a business outcome. And if you're not clear about the goal, then you're probably not building the right stuff.
I cannot agree more. I think as PayPal, we've been benefiting so much from AI solutions for our fraud detection. Like I was telling Yaron, 0.1% of our model improvement means so much for the company. So I actually have a team of machine learning scientists. They don't do anything else but to improve these models every single day. So that's really hard. We really show people the money at the end of the day. That's what motivates the people. And also, again, I should also say, if we can help our customer have a better or easier experience, we stop one more fraudster from entering the global ecosystem. That would be an achievement. The one thing I want to add is, I used to tell people, if we don't know how to measure, I'm not going to build any solution for you. So actually, in the beginning of any solution, first let's ask, what's the goal? And then how do we measure? Do we know how to measure it? Do we need to instrument any more data points in order to measure it? Until that all happens, I don't even talk about sophisticated AI.
How many times have you sat with your data scientist teams and said, okay, but what's the definition of good here?
Exactly.
Just tell me what's good. And then everybody looks at each other. And things go quiet, especially on a Zoom, right? Nobody talks. But if you can't define why are we building this model, what's the definition of good, then stop and figure out the definition of good, and then you can build something.
And you see that it kind of comes back to trust, right? So you get into, well, I can trust my radiologist. How can I trust this machine learning model? I can trust my doctor. How can I? And that comes back to machines with humans. I mean, Deloitte's branded this concept of the age of with. The information age, the industrial age. Now we're in the age of with, right? With machines and AI with humans. But you arm a clinician with the AI, and it's a very powerful combination.
Yeah, to me, to drive adoption, there are a couple of critical factors. One is when lots of revenue is at stake, right? Billions of dollars for e-commerce at Rakuten, for example. The business owner tend to be cautious, right? Because there's a lot of money at stake. When you change the model, what's impact to this quarter's number? I think the first thing is to give them insurance to make sure that no epic failure will happen, right? Like all the compliance and regulations, the reputation risk is managed, right? And the second is And once they have the insurance, then they want to say, how can you help me to grow? Like, what are the data utilization you can grow like a 10x so the revenue grow, right? So these are the two critical things, in my opinion. Give them insurance to avoid epic failures, then make sure that we have the upside in terms of business growth.
I think earlier today, to that point, we were talking about the cost of being wrong, right? So where you've got huge growth opportunities and there's very little cost of being wrong. And one example of that is, there is a cost of being wrong, but just across the bay was pioneered this technique called CRISPR. And if you've heard of CRISPR, it's about genetic editing, right? You can go out and knock out a single gene, and then you look to see what in a cell in a dish, basically, or in a well, what is the effect of that knockout, right? And so they've developed the Broad Institute in Berkeley, and a lot of organizations are working on this, but they've built models that can interpret what happens when you knock out a single gene. And then you start to look at, okay, well, if I knock out this gene in this cell and this gene in this same cell type, am I seeing similar changes to the cell phenotype? So are they connected in a pathway? Are they in this cancer pathway? And if I can modulate that with a molecule, then I can help, regulate the disease or cure the disease. And what you find is that, the cost of being wrong there, people aren't going to die. You might make you're in a single cell, right? So you're not going to hurt anyone. But it's an experiment. It's experimental type work. You might make a bad investment decision, which could be pretty damaging but those things are all controlled, right? Whereas if you actually have something out where you're trying to make a decision around giving a drug to somebody who's right there going to live or die based on what you give them, the stakes go way, way up, right?
Yeah,
and so
and you can see that across, right? So nothing against our advertising and marketing colleagues in data science, but a mistargeted ad, the cost of being wrong, not so bad. At least they know about the brand, right? In self-driving cars, the cost of misidentifying a person walking down the street, the cost is not tolerable, right? And so those are, I think, two really good uses of machine learning. Everybody's familiar with them, but there's just a totally different cost curve.
And that brings up the comparison to humans, right? So a lot of AI adoption is about helping people understand. I can't tell you how many times I've gone into a meeting with somebody who's not familiar with AI. They run a business, and they're like, "What do you mean it's not 100% accurate?" I thought this AI stuff was supposed to be 100% accurate, and obviously you guys all know why. That's not going to happen. But is it better than human performance, right? So you see a lot of times where you have experts in a medical discipline, or you have experts in some other discipline, and they're labeling data. And you run these experiments and you find that, well, the AI, maybe it's not 100%, but it's better than the human. And you get into that with self-driving cars too, right? If 100,000 people are killed every year in automobiles, and we go to 100% autonomous vehicles, and 50,000 people are killed every year, we've cut the death rate in half, that would be a good thing. But are we ready for that as a society? With politically, legally, there's a lot to that as to whether or not that's going to be a viable thing.
Yeah, our responsible AI program also started with, again, a good risk assessment of different use cases. And you put a risk level to different use cases. And also the same concept can apply to, let's say, on the data side. For all the input data we are using, actually we put a risk level when it comes to privacy. What does this mean? And then when our AI scientists design the solution, they have all this information in mind. To my earlier point, right, it's much better when you design things in a way that will work down the stream instead of kind of coming back to fixing things.
So I wanna go to talking about this cost of being wrong, right? And so from our perspective, from a purely technical perspective, there's the type of failure that we're kind of like the most worried about is what we call silent failures or silent errors. So this is where data point comes into the model, prediction comes out, right? So operationally, the model is doing what it's supposed to do. It's like it's putting out a prediction, right? But but then we know that prediction is wrong. So like that's kind of like I think kind of we spend most of our time thinking about like how do we detect, right, when those predictions are coming out of the model they're actually wrong. So we call these silent failures, right? And I'm curious, like, is that something that at the organization that you were thinking about, like that you're thinking about these silent failures, and then when you're thinking about them, like I guess kind of like how do you what do you think are the risks and what are some measures to like avoid these things?
So we deal with people, right? That's everything in our company is about dealing with things that affect people. A silent failure, if I misclassify a job title when we're doing compensation benchmarks, is not as important to us, right? There's one data point out of 30 million that week, and then we'll mop it up again another week. A silent failure, if we're doing job recommendation, is a really bad thing, right? Particularly if we're trying to build a diverse community inside of a company or something like that. It's a very bad thing. So we spend an awful lot of time analyzing those errors as much as we do about analyzing, positive results. In fact, we probably spend more time on the negatives, right? I'm not even sure if those are type 2 errors. I believe they are. So we'll spend more time looking at those and trying to correct those, or trying to understand at least the context in which they happened, because they affect an individual person and their opportunities. And so we want to make sure that our arms around them. Again, it gets into that cost for us.
In our most critical applications, I think luckily, this silent failure will not be silent forever. At some point, we will get some feedback, right? So, yeah. But of course, our goal as a team is not to wait that long, right? So bring this up as much as possible. So again, building a good feedback system and learn as we go, and then try to bring this up more and more upstream. So I think the key here we have learned is actually the more upstream we do this, actually the easier and also the better.
Yeah, I think the silent failure is the most dangerous one because it often hits you at the inconvenient times. That's why I feel like the unit test is the most important. How do you identify the problem at the source, right? When developer, data scientists are building the model, writing the code, what is your expected value? What's your expected range? The frontline people knows it best, right? How do you kind of code it and have the monitoring in place from the start?
So Ting, following up on this, we're talking about kind of unit tests and basically things that we use in software. So I'm curious, how do you see the, kind of the difference between, AI development or ML development, right, and software development when it comes to the issues around, testing, integrity, things like that?
Yeah, so I came from a software engineering background and not traditional data science per se. So, but I think the difference I see is machine learning is a lot more about statistics and probability, right? And the software engineering is more deterministic, where you have expect an output that it will come. So it's a lot more difficult when everything is a variable. So that's also very important to kind of maybe you can even use machine learning model to do unit testing, right? Many years ago, I worked with a company that's using machine learning to do the data curation. So I think there is the counter of using machine learning to solve machine learning problems.
But that said, right, the software engineering discipline, and again, I came up on the data science side, but I've been running teams of engineers for a long time. There's a lot that the data science community can learn from the software engineering community. An awful lot, right? Just sort of the discipline about even having a stand-up. Every morning at 9:15, wait, I'm in San Francisco. Every morning at 10:15, okay? Go across to Phil's, get a coffee, come in, have a stand-up and review the day's results. This is an important concept. So if you roll back 20 years ago here in San Francisco, there used to be a company called Slide. Max Levchin, one of the original PayPal guys, had a company called Slide. And what they did was, when Facebook came out, they were the first thing that would poke. So I don't know if people remember, but Facebook all started with poking. And then they could throw chickens at people and sheep at people and all this other stuff. That was what they started with. So the design of the chicken or the design of the sheep changed their revenue. So every day they would come in and they would look and see those results. It was the very earliest data science type recommenders and things coming into the industry. This wasn't that long ago now. It's 15 years ago. It seems like ancient times. But every day they had a stand-up. And that notion that data scientists could take away and think about that morning stand-up that software engineers do. Look at the failures from the night before, decide what everybody's going to go work on, fix, and iterate and iterate and iterate, I think is an important concept from software engineering that the data science community shouldn't lose.
Maybe this means like the line will really blur. I know this fascinating machine learning application, which is in the chip design, where it gets so complicated that actually engineers start to treat it as a black box and start using machine learning to tackle it. So maybe one day, like again, reading the line will blur, can learn from each other. On the process disciplines, I cannot agree more.
Yeah, actually, Jack, what you said reminds me, before I worked on search engine, I worked on payments and commerce. So I remember I was used to drive all the security penetration tests, just to simulate all the best cases that could happen, right? Like using the production data in the past as a simulated test set, to do the penetration test.
And now we use reinforcement learning.
Okay, so I guess kind of maybe the last question for today. I'd love to get, we have a lot of people who are who are watching us now, people who are interested in machine learning integrity, and I think that for a lot of them, we have a lot of people, we have a lot of customers who are interested in okay, what are some best practices that I can adopt today, right, so that I can boost the level of machine learning integrity in my own organization. I know you guys are doing a lot of things, so I'm curious, what are some of what are some kind of very, very easy recommendations that you have for leaders in these organizations?
I would start with just start, right? An awful lot of times the hardest thing is taking the first step. So the first step that we took, sounds like a very similar thing at PayPal, was to set forth the principles that we wanted to achieve. That was actually easy. Finding the tools and everything else then becomes a little bit harder, but it actually falls down from there. So our first thing was deciding as a company what we wanted to be, what we wanted to represent, and how we wanted to treat our information and our machine learning models. And we had a very open discussion about it. From there, the mechanics of getting it done, the mechanics of getting getting the culture to think about it became easy. If we hadn't taken the first step of setting down the principles, I think we'd still be arguing 3 years later.
I think it's about really embedded in a culture to the point that ML integrity is not an option, it's actually a must-have. So it's really integral part of the entire process. So anyone who wants to take machine learning from lab to factory, you just have to do it.
Yeah, I mean, I think culture is key, and it starts with the framework around, how do you manage trustworthy AI in your organization? What are your expectations of people? And then live those cultural values, right? You have to enforce that peer-to-peer. You enforce it across the organization in terms of your expectations, how you reward people, all of that. I think it's imperative for an organization to have a quality and risk management program around AI. So we have it around software engineering. It's critical to our business. It's critical to what we do. Software is when you have those functions in your organization, and AI is no different. And understanding where your risks are, how you can mitigate those risks, what tools you give to data scientists to help them be successful in managing those risks, and then how do you control what you're putting out in front of your customers? How do you make sure that what you've put out to your customers has been tested appropriately, is monitored appropriately, and that you've got metrics and artifacts to back that up, and that you can stand behind. And that's going to just improve your overall risk profile and help you be much, much more successful in deploying AI out to your customers.
Mm-hmm. Yeah, I would say do it first. So the machine learning integrity it will give you the confidence, right, in order to do bold innovations and creating new models. This is like in the software engineering world, the most important thing, especially for services, online services, the most important thing is production quality, right? Like once you have the production quality, make sure your website or your search or your services is up 24/7, then you can develop the next generation model, right? Similarly to machine learning integrity, once you have that assurance, you can go bold and at fast speed.
That's right. That's right. And remember, early in our careers, you used to say the white smoke test. You got to plug it in, and if white smoke comes out, unplug it quickly. But this idea of having that production quality, that reliability, that speed, you can't start to innovate on the edges without that.
All right. Well, Wei, Jack, Ting, Ed, thank you so much, for joining us here in San Francisco in the beautiful Dock Bench. We learned a lot. Thanks for spending the day here. And thanks for everybody who's watching us. Looking forward to more machine learning integrity talks. Thank you.